Hey, hi everyone. Welcome back to live stream session with Axiom's intern. Today's agenda is to review the progress, what they did with their white label projects they are working on. Earlier, right from the analysis of the entire project, they explain the utility, they explain the features, they explain the complete wireframe of the applications, the UI part. Later on, they worked on the front end development, database structure. After completion of all these analytical things, they pitched up to the investors how their application is good enough for the investors, what kind of benefits they'll be getting. And after that, now the project development is in the phase of backend API development. As you know, the entire technical stack they'll be using, that is Moon, where React they are using for the front end development, and Node.js they are using for API development. Today's session is how they developed backend code, how they developed APIs, how they document all the APIs required to the application, how they will test it as it's a session for the entrance. They have to explain us everything what they are doing server side, right? Because up till now it's just analysis, front end, and the database structure they explain. The agenda for today's session is to go to the next level of API development. So I'll open this forum to all five projects group who are working on the white label applications. So expecting that they'll be elaborating, they'll be explaining the progress regarding server side development, API development, documentation, testing, and many more, so that we all get convinced with the progress what they are doing on the server side. I'm handing over this session to Team Axiom to manage the next presentations. Over to Axiom Entrance team.
Good morning, everyone. Today I am going to represent on API integration and testing in our Elite Care Healthcare solution. Our project is built using React.js, Node.js, Express.js, and MySQL. API play a vital role in connecting the front-end, backend, and database to provide secure and real-time healthcare services. First, let's understand what an API is. API stands for Application Programming Interface. It is a bridge that allows two different software applications to communicate, exchange data securely. For example, when a patient book an appointment in Elite Care, the front end sends a request to the backend through an API. The backend processes the request, retrieves the required information from the MySQL database, and sends the response back to the frontend. Finally, the patient can see the appointment confirmation on the screen. Without API, communication between the front end, back end, and database would not be possible. API make the entire system faster, secure, and efficient. Now let's understand why API are important. The main purpose of API is to connect the front end with the back end and enable secure communication between different systems. API help us share information in a real time, reduce manual work, improve application performance, support scalability, and integrate third-party services. In our Elite Care project, API are used for patient login appointment booking, viewing medical records, online payment, and video consultation. So, API make healthcare services faster, more reliable, and user-friendly. API development consists of two main stages, API design and API implementation. During API design, we first analyze the business requirement and identify the feature needed in the application. Then we create a API endpoint such as login, patient, and appointments. We select HTTP methods like get, post, put, and delete. The request and response data are exchanged in JSON format, and security is implemented using JWT authentication and API keys. After designing, we move to implementation. We develop the backend using Node.js and Express.js, connect it with the MySQL database, valid user requests, test APIs using Postman, and finally deploy and monitor the API to secure smooth performance. An API key is a unique secret code used to identify and authenticate an application before it accesses an API. Its main purpose and authentication, authorization, security access control, and usage monitoring. In our Elite Care project, we use several API keys including Google Map API, OpenAI API, BrowserPay API, Firebase API, and Twilio API. We can think of an API key as a digital identity card and allow only authorized applications to securely access third-party services. Elite Care is an AI-powered healthcare platform that connects patients, doctor, hospital, and administration through a single digital system. Patient can register, book appointment, consult doctor online, access digital prescription, view medical record, and make secure online payment. Doctor can manage appointments, prescription, and patient record, while administrator can manage user, hospital reports, and system operation from a centralized dashboard. The project is built using React.js, Node.js, Express.js, MySQL, REST API, JWT authentication, and AI services, making the platform secure, scalable, and easy to use. In EliteCare, different API are responsible for a different functionalities. The authentication API provides secure login. The patient API manages patient information. The doctor API handles doctor dashboard. The appointment API is used for booking appointments. The prescription API manages digital prescription. The payment API enables secure online payment. The notification API sends SMS and push notification. AI system checker helps predict possible disease based on symptoms. Google Maps API helps user find near hospital, while the medical records API stores and retrieves patient health history. Together, these APIs create a complete and smart healthcare ecosystem. Now, I would like to explain our project progress. In the last session, we successfully completed the database dashboard integration. We connected the MySQL database with the backend, retrieve data through REST API, display real-time information on the dashboard. Currently, we are working on API development, integration, and testing. We have implemented REST API using Node.js and Express.js. Integrate the front end with the backend API, tested them using Postman, implemented JWT authentication, and ensure smooth communication between the front end, back end, and database. So far, we have completed the UI and UX design, dashboard layout, database design, REST API development, front-end back-end integration, JWT authentication, API testing using Postman and crowd operation for a patient, doctor, and appointments. Currently, we are working on API system checker integration, Google Map API, gateway, emails and SMS notification, and overall performance optimization and bug fixing. The features we further improve the functionality and user experience of our platform. Next milestone include completing all third-party API integration, improving application security, performing end-to-end testing, enhancing responsive UI, deploying the project to the cloud, preparing documentation, and delivering the final project demonstration. During deployment, we face several challenges such as API integration issue, JWT authentication setup, front-end back-end database connectivity, API testing, performance optimization, and responsive UI compatibility. We address these challenges through proper debugging, testing, and teamwork. To conclude, they enable secure communication between the front end, back end, and database. API key ensures secure access to third-party services, while API testing guaranteed that the application performs reliably before deployment in elite care. API automate healthcare services such as patient registration, appointment booking, online payment, digital prescription, notification, and AI-based healthcare support. Overall, a well-designed API architecture improves security, scalability, performance, and provide a better user experience. That concludes my presentation on API integration and testing in the elite care healthcare solution. Thank you for your attention. Now, I would like to hand over to my teammate for next demonstration. Thank you.
So hey everyone, today I will explain the backend structure and authentication APIs of our Elite Care project. As you can see, I have created a separate backend folder which handle all the server-side operations like API creation, authentication, database connection, and business logic. Inside the backend folder, I have different folders for better code management. So first we have config folder. This folder contains the database connection file. In our project, db.js file is responsible for connecting my Node.js backend with my SQL database. Whenever the server starts, this file establishes a connection with the Lightcare database. Second, we have controller folder. This folder this folder contains the main logic of my APIs. Whenever a request comes from Postman, it first reaches to the controller where the actual processing happens. In our project, we have two controllers. The first is authcontroller.js and the second is patientcontroller.js. Authcontroller.js is responsible for user registration, login, profile, update profile, forward password, and logout. After that, we have middleware folder. This folder works as a security layer in our application, which we have created using auth middleware.js, which verifies the JWT token. Whenever a user accesses protected APIs like profile or dashboard, middleware checks whether the token is valid or not. If the token is valid, the request is forwarded further. Otherwise, it returns as an authentication error. After that, we have model folder. These models are used to communicate with the database. User.js contain all the user-related database queries. For example, creating a new user, finding user by email, fetching user details by ID. The controller sends requests to the model, and the model performs operations on the MySQL database. After that, we have routes folder. This routes define all the API endpoints of my application. We have created two routes files. First is auth routes.js. This file contains authentication APIs like register API, login API, profile API, logout API, and forward password API. And the second we have is patient_route.js. This file contains patient-related APIs like patient dashboard, etc. After that, we have this .env file. This file stores important configuration details like database username, database password, database name, and JWT secret key. We have stored this value separately for security purposes. After that, we have server.js. This is the main entry point of my backend application. In this file, we have initiated the Express server, connect middlewares, and load all routes and start my application on port 5000. So that's how the complete backend flow. So the first we need to open the new terminal. After that, we need to type cd.backend. After that, npm run dev. So as you can see, there's written MySQL connected successfully. That means our database is connected on server. So that's how the complete backend flow. First, the user sends a request from Postman. The request come across the different route. Route forward the request to the controller. Controller processes the request and communicates with the model. Model interact with the MySQL database, and after processing the response, which is sent back to the user. Using this structure, my backend code is organized, scalable, and easy to maintain. Now I would like to explain the front-end folder structure of our project, in which has been developed by React.js, White, and TypeScript. This structure is designed to keep the project modular, maintainable, and scalable by separating the application assets, source code, config file, and dependencies. The first we have asset folder. This folder is the asset folder which stores all the static resources used in the application such as images, icons, logos, fonts, and other media files. Keeping these resources in a separate folder improves project organization and makes asset management easier. After that, we have Node modules folder. This folder contains all the project dependencies and our third-party packages which has been installed using npm. These libraries are automatically downloaded based on the package.json file and are required for the application to run successfully. After that, we have SRC folder, which holds the core directory of our front-end application, which contains all the complete source code, including React component pages, routing APIs, and integrations. After that, we have .env file. This file provides a template for environment variables required by the project. Developers can copy this file to create a .env file and configure API URLs, application setting, and other environment-specific values without exposing sensitive information. After that, we have index.html. The index.html file is the main HTML template of a React application. It contains all the root element where the React application is mounted and rendered in the browser. After that, we have package.json. This file contains important project information, including the project name, version, dependencies, and development dependencies as well. And npm scripts such as starting the development server, building the application, and previewing the product build. After that, we have server.ts. This file is written in TypeScript and it is responsible for server-side configuration or development server functionality, depending on the project requirement. So to run this server.ts, we need to open new terminal and need to type cd.frontend. After that, we need to type run npm run dev. As you can see, there is written localhost 3000. We need to follow the link and you can see the UI. So next I'm going to demonstrate the authentication module of our EliteCare. This is the module which is developed using Node.js, ExpressJS, MySQL, JWT authentication, and Bcrypt for password encryption. The main object of this module is to provide secure user authentication, include user registration, login, password recovery, and logout functionality. The first is the register API. The first API is the register, which you can see the method is post. API endpoint is /API/auth and register. Below there is the request body, the name, email, password, phone, and their role. When this request is sent from the postman, the server first validates all the required field after validation. It checks whether the email address already exists in the MySQL database. If the email is unique, the password is encrypted using the Bcrypt hashing algorithm. before being stored. This ensures that the actual password is never saved in the plain text. Finally, the user information is inserted to the user table and the server returns a successful registration response. As you can see, the success is true and the message is registration successful and the user ID as well. This response confirms that the user account has been successfully created and assigned a unique user ID. Second is the login API. This second API is the login which authenticates registered user and allows them to access protected resources. The method is post and the API endpoint is /auth/login. The request body contains the email and password of the user. So when the login request is received, the application first searches for the user based the provided email address. If the email exists, Bicrypt compares the entire password with the encrypted password stored in the database. If both credentials are valid, the server generates a JWT, which is JSON Web Token. This token is digitally designed and it is required for accessing all the protected APIs in the application. JWT provides secure authentication without storing session information on the server. So as you can see, the success is true and the message is login successful. And below is the token, which is the JWT token key. The generated JWT token is copied and included in the authorization header as a bearer token whenever the user wants to access the secured APIs. After that, we have forget API, which is forget password. This functionality is used when user forget their account password. The method is put and the API endpoint is /forgot password. The request body contains the email of the user. This application first verifies whether the provided email exists in the database. Currently, the API flow which has been implemented successfully and email services such as Node Mailer will be integrated automatically, send password recent link or OTP to the user registered email address. As you can see the response which is true and the message you can see is password insert link. This response indicates that the password recovery process has been initiated successfully. After that, we have logout API. This fourth API is the logout API, which is used to securely and the user authenticated session. The method is post and the API endpoint is /auth/logout. When the logout request is made, the server invalidates the current authentication session. On the client side, the JWT token is removed from local storage or session storage, preventing any further access to protected APIs until the user logs in again. The response you can see is true. Message is logged out successfully. This response confirms that the user has been successfully logged out of the application. Our last and the fifth API is delete account API, which allows an authenticated user to permanently delete their account from our EliteCare system. The method is delete and API endpoint is /auth/delete account. For this, we need to take the bearer token, which is JWT token. This protected API, which means the user must first log in and obtain a valid JWT token. This token is then passed in the authorization header as a bearer token. The authentication middleware verifies the token before allowing access to this endpoint. When the delete account API is called, the server first verifies the JWT token using the authentication middleware. After successful authentication, it identifies the logged in user from the token and permanently removes the corresponding user record from the MySQL user table. This ensures that only authenticated user can delete their own account, maintaining both security and data integrity. As you can see, the success is true and the message is account deleted successfully. This successful response confirms that the user account has been permanently deleted from the database. After deletion, the JWT token becomes invalid for future requests and the user must register again if they wish to access the system. So next I'm going to explain about the database implementation. As you can see, first we need to type the email on the login API. After we need to send the button send, then you can see the response which is success true and the message is login successful. Our project uses MySQL as the relational database management system. We created a database named EliteCare, which stores all the application related data, the authentication module, which user able to maintain user secure information. So first we need to type some command, and as you can see, we added ram.@gmail.com, which is successfully added into our database. Whenever a new user registers through the register API, this information is immediately inserted into the MySQL user table. We can verify the inserted records directly in MySQL Workbench. During login, the system retrieves the user encrypted password from the table and validates it using Bcrypt before generating the JWT token. So that's all from our side. Now we like to hand over the live to the next team, which is going to present their project.
Good afternoon, everyone. Welcome to the technical demonstration of API testing and API integration for the Food Mitra project. Today's session covers the complete API flow, including API fundamentals, authentication using API keys and tokens, API testing with Swagger and Postman, and finally API integration between the front end and back end through a live demonstration. Before we begin the live demonstration of the FoodMitra application, let me briefly walk you through today's agenda. First, let's understand what an API is. API stands for Application Programming Interface. It acts as a bridge that enables communication between the front end and back end. In our FoodMitra application, whenever a user logs in, views restaurants, searches for food, or places an order, the front end sends an API request to the backend. The backend processes the request, interacts with the database, and returns the required response to the application. Next, we will discuss API authentication. Since our APIs handle important user and restaurant data, they need to be protected from unauthorized access. We use API keys and bearer tokens to ensure that only authenticated users and applications can access the FoodMitra's API securely. Now let's look at Swagger. Swagger provides the API documentation for the FoodMitra application. It displays all the available API endpoints along with their request methods, required parameters, and response formats. This gives developers a clear understanding of the API available in the system before they are used. After understanding the API documentation, we'll move on to Postman. Here, we will test the FoodMitra APIs by authenticating with a bearer token and sending different HTTP requests such as GET, POST, PUT, and DELETE. We will verify that each API working correctly by checking the responses returned from the backend. Once the APIs are tested successfully, we will see how these APIs are integrated with the FoodMitra application. The front end communicates with the backend through these APIs to retrieve restaurant details, manage user accounts, process orders, and display real-time information, ensuring a smooth user experience. Finally, we will conclude with a live demonstration of the complete API workflow. We will generate the authentication token, test the APIs in Postman, and show how these APIs are integrated in the FoodMitra application to perform real-time operations seamlessly. Now, let's take a look at the key APIs that power the core functionalities of our FoodMitra application. The Sign Up API is used to register new users. It validates the user details, creates new account, and stores the information securely in the database. The Login API authenticates user by verifying their credentials. After successful login, it generates an authentication token that is used to access secured APIs. The category API fetches all available food categories. This helps organize the menu and allows users to browse different food options easily. The product API retrieves the details of food items, including their name, description, price, availability, and images. This information is displayed to users while they browse the menu. The Coupon API validates promotional or discount codes entered by the user. If the coupon is valid, it calculates the applicable discount and updates the final order amount. These APIs work together to provide a seamless user experience by securely managing user authentication, retrieving data, and enabling real time communication between the FoodMitra frontend and backend. Now, let's understand why vendor side APIs are an essential part of the FoodMitra platform. Vendor side APIs enable seamless communication between vendors and our platform, making day to day operations faster, more secure, and efficient. The first advantage is real time synchronization. Whenever a vendor updates product details, prices, or availability, the changes are synchronized instantly with the platform. This ensures that customer always see the latest information. Next is inventory control. Through these APIs, vendors can easily manage their inventory, pricing, and product availability without any manual intervention, reducing the chances of errors. The third benefit is secure access. Vendor APIs use secure authentication and authorization mechanisms, ensuring that only authorized vendors can access and manage their business data. Next aspect is scalability. As more vendors join the FoodMitra platform, these APIs efficiently handle the increasing workload without affecting system performance. We also have data consistency, which ensures that the same accurate data is maintained across all connected systems while preventing unauthorized modification. Finally, system integration allows vendors to connect their own software, such as inventory management or billing systems, with FoodMitra. This creates a smooth and automated workflow without requiring duplicate data entry. Overall, vendor side APIs form the backbone of FoodMitra's vendor management system by providing secure, reliable, and real time communication between vendors and the platform. Thank you for your time and attention. We hope this session has provided a clear understanding of API testing and API integration. Now, I'll hand over this session to my teammate who will present the live demonstration of the vendor module API.
Thank you for explaining the overall architecture and implementation of the Code Mitra vendor management system. Now I continue with the live demonstration. During this session, I will demonstrate the complete API workflow. First, I will briefly show our API documentation using Swagger. Then I will test 5 vendor API using Postman and verify each operation in PostgreSQL using pgadmin. Final, I will move to the front-end application and demonstrate how the same API are integrated with the user interface. Now, before testing the API, let's first look at our API documentation. We have integrated Swagger into our backend. Swagger automatically documents all the available REST API. Their request method require parameter, request bodies, response format, and status code. This make it easier for front-end developers, tester, and other developers to understand and consuming the API without referring the external documentation. Now here we can see all vendor management API organized into different sections. For today demonstration, I will focus on these 5 API. First is vendor registration, vendor login. Third, cre create vendor, create product, create coupon. Now, Swagger also allows users to inspect each endpoint. We can view the request body, expected response, authentication requirement, and HTTP status code. Although Swagger also provide try it out features to test API directly for today. Today demonstration, I will use Postman because it provides a clearly view of the request and response flow. Now let's move on Postman API testing. First, I am registering a new vendor. Here I provide vendor email, password, name, phone number, and business name. Here I enter email, password, name, phone number, and business name. Now I click send button, play wait for the response. As you can see, the API returns to 01 created status, which means the vendor has been registered successfully. The response also returns the vendor ID and restaurant ID. Here vendor and ID and restaurant ID. Here we can see. Now I switch the database. Here we can see the created. Wait for the response. Now I will verify the database. Here you can see the newly created vendor, the email, name, phone number, business name, an encrypted password and stored successfully. This confirms that API connected with PostgreSQL. Now let's move Postman. I will using the register email and password. Password. Then I click send. Wait for response. There is some issue. Password is incorrect. Here I enter email. Now the login is successfully. The I can verify the credentially after successfully authentication. It shall get user access token and refresh token. Now this access token is used for authentication is all protected API. Here enter the access token and copy the refresh token. Copy refresh token and here paste the refresh token. Here is restaurant ID. Copy restaurant ID and paste the restaurant ID. Now, now I am creating a food category. Here is the restaurant ID. I provide the restaurant ID receiving during registration the category name and description. Here restaurant ID, copy and paste the restaurant ID. Then restaurant return the details, restaurant ID. Yes, for the restaurant ID. The category, I click the send, wait for the response. Here is a response to 01 created successfully. The response return the category ID, category ID will be required, create product. Now I switch the PostgreSQL. Here we can see the category refresh. Here category table we can see the newly created category, the category ID, restaurant ID, category name, description slug have been stored successfully. Now let's move Postman. Next I am adding a product. Here required the category ID and restaurant ID. Restaurant ID. Restaurant ID. Here name, simple name. Here required the category ID and restaurant ID. Now I click the send button. Here, see the response. The product has been created successfully. The response contain an product ID and restaurant ID, category ID, okay, all of it. And I verify the database, see the product. Here we can see the product. This product is linked with corrected category and restaurant ID. Here we can see this demonstrates the relationship between category and product. Now go to the Postman and create the coupon. Finally, I will create coupon for this restaurant. I fill the all detail to providing coupon for here. Here I enter the restaurant ID. Click the send button. Look for the response. Here coupon created successfully. This is the database PostgreSQL and here is a table. You can see the coupon table. We can see newly created coupon along with restaurant ID, coupon code, discount type, discount value, and status. This confirms that the coupon has been stored successfully in PostgreSQL. The client send a HTTP request using Postman. The backend validate the request and process the business logic. Then the backend store the data in PostgreSQL. Finally, the server send a JSON response back to the client. After every API call, we verify the inserted data directly in the database. Today, I demonstrate successfully 5 API of the Food Mitra vendor management system: vendor registration, vendor login, create category, create product, create coupon. I also verify every operation in PostgreSQL database, provide that the API and data are fully integrated. This demonstration is complete end-to-end workflow from client request backend processing data base stored to the API response. Thank you. I am happy to answer any. Now, my team met Jia will demonstrate further front-end integration.
So far, we have tested all 5 vendor APIs individually using Postman and verified that every operation is successfully stored in our PostgreSQL database. Now, let's move to the front-end application. The purpose of this demonstration is not to explain these APIs again, but to show that the same backend APIs are fully integrated with the user interface. Everything that we tested manually in Postman is now working seamlessly through the front end. Before starting, We'll open the browser's developer tools and the network tab. This show allows us to observe the API request generated by the frontend in real time. So whenever we perform the action in the UI, we can see the exact backend API being called. Let's begin with the login page. Earlier in Postman, we successfully tested the login API using these credentials. Now, instead of sending the request manually from Postman, the frontend will send the same request automatically. Let's enter email, password, and click on sign in. As we can see, the frontend has called the same login API that we previously tested in Postman. The backend validates the credentials, generates the JWT access token, and returns the response. The frontend stores this token and uses it for protected API request. Once authentication is successful, the dashboard is displayed. After successful login, the application navigates to the vendor dashboard. Now, the frontend automatically starts communicating with the backend to load vendor related data. This entire process happens through REST APIs without requiring any manual interaction. Next, let's move to the category management. Earlier, we created the category using Postman. Now, we can see that the same category is visible here in the front end. This page automatically calls the category API. The backend fetches all categories stored in PostgreSQL and returns them at JSON. The frontend then renders the data as category cards. This confirms that the category API is successfully integrated with the frontend. Let's move to the product page. Similarly, this page is connected with the product APIs. Earlier, we created the product through Postman. Now we can see the same product displayed here. The frontend requests all products from the backend. The backend retrieves the data from PostgreSQL and returns the response. The frontend then displays the products dynamically. This demonstrates that the product API is working correctly with the user interface. Finally, let's move to the coupon management page. Earlier, we created the coupon using Postman. The same coupon is now displayed in the front end. This page calls the coupon API to retrieve all available coupons for the vendor. The backend returns the stored coupon data and the frontend renders it in the interface. This confirms that the coupon API is fully integrated with the frontend. So, during the first part of the demonstration, we manually tested each API using Postman and verified the corresponding data directly in the PostgreSQL. In the second part, we demonstrated that those very same APIs are integrated with the front-end application. Whenever a user logs in or opens the categories, products, or coupons pages, the front-end automatically communicates with the backend through REST APIs and retrieves live data from the PostgreSQL database and displays it in the user interface. This completes the end-to-end workflow of the FoodMitra vendor management system from API testing, backend processing, database storage, and finally front-end integration. Thank you for your time and attention. That's all about our FoodMitra API keys and demonstration. Now I'll hand over this session to the next team for the demonstration.
Good morning, everyone. Today's I am presenting. Today I am presenting our government solution project, which focuses on API development, testing, and content integration. In this presentation, I will explain our project overview, the technology we are using, the development progress, the current of project status, the APIs we developed, and finally demonstrate how we tested and integrate them with the front end. Let's begin with the project overview. Fargoth is the modern garment e-commerce platform designed to provide customers with a secure, fast, and user-friendly online shopping experience. It allows users to create account, log in securely, manage their professional
person profile and interact with the application through a responsive interface built using a React. The project follows a full stack architecture where the React frontend communicates with a Node.js and Express.js backend, while all users' information is securely stored in MySQL database. To ensure security, we implement JWT authentication for user authorization and bcrypt encryption for password protection. The complete application is developed using React.js, HTML, CSS, JavaScript, Node.js, Express.js, MySQL, and Postman for API testing. Currently, our project is about a 60% complete, and most of the core functionalities have already been implemented successfully. We have finished developing the responsive frontend, user registration and login modules, user profile dashboard, profile update, password change, forget password, logout, and delete account features. Along with these modules, we complete backend APIs development, integrate a MySQL database, implement JWT authorization, and bcrypt password for encryption, tested all APIs using Postman, and successfully connected the React frontend with the backend. According to our development timeline, the planning UI/UX design, front-end development, back-end APIs, database integration, and security implementation are complete, while deploying is the next phase of our project. At present, the front-end development, back-end development, MySQL database integration, REST APIs implementation, JWT authentication, password encryption, API testing, React integration, and the complete user management module have been successfully completed. The next phase of the project includes the developing the product management modules, shopping cart, wish list, order management system, payment gateway, integration, admin dashboard, email notification services, and finally deploying the application to the cloud. During development, we face several challenges such as implementation, secure authentication, password hashing, token validation, protected routes, database synchronization, and smooth communication between the front end and back end, all of which were resolved successfully. Other future roadmap is to extend the application front end from the source modules to the product management. Then order and payments followed by the admin dashboard and cloud deployment. Now I will demonstrate the APIs development for our application. We have successfully created the REST APIs for user registration, login, profile retrieval, profile update, password change, forget password, logout, and account deletion. The application follows a simple architecture where requests are sent from the React frontend to the Express APIs layer, processed by the Node.js backend, and the data stored or retrieved from the MySQL database. We secure responses provided through a JWT authentication. During the live demonstration, I will show how the APIs were developed, tested using a Postman, connected with the React application, and how the data is securely stored and retrieved from the database. This brings me to the end of my presentation, and thank you for all our valuable time and attention. I hope presentation gave you a clear understanding of our garment solution projects, include its architecture, API development, testing process, and front-end integration. For next practical demonstration of our project, I hand over our presentation to my teammates.
Good morning, everyone. Today I will demonstrate the backend folder structure of our Argos project. Now here we can see config folder in db.js. It creates a connection of MySQL with our database, which is Argos_db. If in any error, it will show database connection fail, else database connected successfully. The now next folder is controller. Control contains all the API logic of our backend. Now we send a full name, email, phone number, password, gender in request.body. If something is missing, it will show an error. All fields are required. In db.query, we again check if email exists. It will show an error. Email already exists. If and again and in db dot in database we inserted data like a full name, email, password, hash password. If everything is correct, it will show a message user registered successfully. So same logic we also written for a logic API, get profile API, update API, change password API, etc. Now next is the middleware. Middleware folder is used for authentication. It verifies JWT token because we use JWT token, allow access to protect our APIs. Now next is routers. Router folder contain all API endpoints and map them to their respective controller function. Now next is the .env file. .env file contains the sensitive information of our project. Our port number is 5000 database localhost. DB port is 3306. Also we use JWT secret code. Now the next folder is the packet.json. Packet.json is used for our required packages like a bicrypt.js, cos.env, express, JWT token, MySQL 2 we have used, and also use Swagger UI Express for API documentation. Now the next dependency is Node1. Node1 used for our start or server automatically when code some changes in code. Now the next is Swagger.js. Swagger.js used for API documentation. It connect with our backend URL, which is written inside the Swagger YAML. Here is the URL, localhost colon 5000, and the next file is the server.js. Server.js is the main entry point of our backend server. Now we have to run our backend server, which is npm run dev. So here you can see our server running on the port 5000 and the database connects successfully. Now I will demonstrate the REST API of our project using Postman. So here you can see this is a Postman, and the first API is localhost colon 5000 API auth register. In a body we send a JSON data, which is full name, email, phone number, password, gender, and using a post method. Now we have to click on send button. Here you can see the status code is a 201 created and a message will show user registered successfully. Now we have to verify in our database, which is used MySQL Workbench. Here you can see the user successfully stored in our database, phone number, password, also bicrypt, which because we use bicrypt, and a gender, male, date of birth, city, state, pin code is not shown because we didn't send date of birth, city, state. Now the next API is the login. Again we send a email, password in request.body. Say click on send button. So first we have to register, because we register using Ritvik Kumar. Again email is Ritvik Kumar. Click on the send button. Here login successfully, and JW and a token also generated using JWT token. Just copy this token for get profile. We use a barrier token. Barrier is a holder. It carry our JWT token. Using get method we send. Here you can see the get profile will show user ID, full name, email, phone number, gender, and date of birth, city is null. Now we have to update our profile. Again verify our JWT token, and request.body we send the date of birth, city, state, pin code, and click on the send button. Here you can see profile update successfully. Now we have to verify in database. Here you can see the date of birth, city, state is also inserted in our database. Now the next is the change password API. User can also change our password using, again here we have to verify our JWT token in request.body. We send old password ABC and the new password is 12345. Click on the send button. Here you can see the password change successfully and status code is 200. Now the next API is the forget password. Here also user can change forget password, email ID, new password. Click on the send button. So password reset successfully. Now the next API is a logout. Logout also we use JWT token for authorization. We send a post method. Click on the send button. Here logout successfully. Please remove the token. Now the next final API is a delete account. Here also we use JW token for authorization. Click on the send button. Here you can see the account deleted successfully. Now we have to verify in our database. Here you can see the our user is successfully deleted. So I have successfully tested all 8 full REST APIs. Now my team will demonstrate how these same APIs are integrated with React frontend. Over to you.
Hello everyone. Before demonstrating the application, I will explain how the front end communicate with the backend. Let's go to the API. We use the exhaust library to send the HTTP requests like get, post, put, and delete. We have created a Axios instance of Exhaust created. This base URL is set the HTTP. We don't have the right to full API URL every time. For example, when we write a API post or login, Exhaust automatically send the request to the HTTP request. Let me run the program. This is the home page of Orgos. User can browse product, view categories and reward points, membership details, and access the shopping with the features. Next, we will go to the register. New user can create an account by entering the details. After clicking the register, the front end sends the post request to the backend. The backend validates the data, encrypt the password using a bcrypt, and store the information in SQL Server. Let me put the details. Here enter a password. Here you can see the user registered successfully. Let me show the in SQL Server. Here the new user is Vedant person. User after we will click to the login. User logging using the email and password. If the credentials are correct, the backend generates a JWT token and sent to the front end. This token is used to access the project APIs. The email is already login. So after we can see the profile icon. After the login, the user is redirected to the profile page. Here, users can create, view, and personal information such as phone number, generate city, state, and pin code. Let me run this. Entering the data. Here the profile update is successfully. Now we'll go to the next change password. Here user can change their password. The backend first verify the old password, then encrypt the new password before saving it. Here we can see the password is changed successfully. Now we are going to the next option, logout. When the users log out, the JWT token remove the users in the redirect to the login page. Next, we will see the delete account. If the user choose a delete account, the backend permanently remove the user record from the database. Here, the data is deleted. Let me show in my database. Here, the data is successfully deleted. That's all from my side. Now, I would like to invite the next team to present their real estate project. Over to them.
Talking about real estate project, we have covered a variety of the things up till now. Like you have seen our website structure. You have seen how we actually successfully implemented the concept of heat maps and gamification. You have also seen how we organize our database properly up to the last stream using Tableau to Power BI and SQL. Now it's time to understand why API plays an important role, because we need to understand that whenever we are deploying the website will be accessed around variety of the users. That's why connection to the user and server plays an important role. That's why API. So for this time we are building our REST APIs using Node.js, Express.js, and MySQL. Now our projects intend to focus on developing a backend and actually a successful functional backend for urbanist reality. We created REST API that connects the frontend with MySQL database. Currently, we have implemented two major API modules, that is authentication and property management. So objective is way more much clear, that we should develop a scalable a backend server which should serve a variety of the purpose like register, login in, and sign up type things. Then then management property listing plays an important role. Also, whenever data comes, updates and deletes, that's why SQL plays a very important role. And also REST exchange data using REST API is also important things, and also support for future front-end integration. This is our overall objective for today's object. Then our backend architecture is way more much simple, like as you all can see in the diagram. So basically the client will come into the website, then it will click any of the things they require. Then the Express server will access the thing, and incoming request will be accepted by Express server and sends the response. Then it comes to the route medium where API defines the endpoints and map them to the controller function. Then comes the controller, which contains business logic, processing request, and interact with the database. And after that, it comes to MySQL database, where it will share the data. Now this is our overall structure, that how our backend will contribute. Then following the backend structure, there are variety of the folder structure whenever we are creating backend. This type of file structure we are following, like config, controls, routes, middleware, server.js, and env and package.json. And it contains a variety of the Node.js files and Express.js files, which usually coordinated to a functional coding structure. So here also plays an important role of user authentication module. Like basically user needs to access the website by creating the account. Then by the created account, he will enter his account credentials, and then the website will give him user ID. So for the user, like you all can see in the diagram, we have a couple of APIs which we are focusing on, like authorization sign up, then validation date, that checking existing email, that encrypt password, and store user in the database, and successful response. This is the concept we are following for the login and sign up concept. Now here you can see how our server to user response will go on. Like basically the user will send the request, then database will check from his credential and also data that available or not, and then the server will respond it. API testing plays an important role because at the end of the day, just creating something is not important, but testing in also. So we are relying for the time we are relying on the Postman, who which will play an important role in API testing and widely industrial user validation tool. Like now it comes to challenges we have faced because API concept is very new for this. So there are variety of the challenges like we faced. Like MySQL is very problematic thing for now, but we tackle it by just a variety of the things. Then also following the syntax and logical errors we are doing. Then API routing thing was also new, so that's why we also face couple of challenges, but tackle it anyhow. Then CRUD implementation is very crucial for the data management. Like basically create, read, then delete operation. Then password encryption is also because data privacy has matters a lot. Then for the future scope, we are focusing on the complete JWT authentication, role-based access, and the exciting feature will be coming by the image upload, property search filter, pagination, Swagger API documentation, and deployment on cloud. Now, since we all know that theory portion sometimes confuse a variety of the users, so my team will be demonstrating you the functional how backend and frontend structure works. Over to my teammate.
Good morning everyone. Today I will demonstrate the building logic by using Node.js, ExpressJS and MySQL in my Backend CRP project. Now I will explain the backend structure of my project. The backend structure is developed using Node.js, ExpressJS and MySQL. I have organized the project into different folders to keep the code clean and maintainable. First we have the config folder. This folder contains the database configuration. Open db.js file. Inside the db.js file, I have written MySQL connection code whenever the backend needs the read and write data. It uses the database connection. This file establishes the connection only is controller folder controls
Application. They receive requests from
application. They receive request from
the root, perform database operations, and send response back to the client. Open the authcontroller.js file. This control handles the authentication related operations. The signup function validates the user data, checks whether the email already exists, encrypt the password using bcrypt, and finally stores the MySQL database. The logging function verifies the email and password. If the credentials are correct, it generates a JWT token, which is later used for secure authentication. Now open the property control.js file. The controller manages all property related operations. Explain each function.
Add property, get all properties and update property, delete property. These functions perform CRUD operations on the property table. Then middleware folder, open auth middleware.js file and add this can check security checkpoints. If checks whether the incoming request contain a valid JWT token. If the token is valid, the user is allowed the access protect APIs. Otherwise, access is denied. Now, root folders. Next, the root defines all API endpoints. Application auth.root.js file will be these routes map incoming HTTP requests to their respective control functions. For example, post API, auth sign up, and post auth login. Then next, env file, project information, and all dependencies such as database host, user, DB user by password, and JWT secret. Next, we will be open package.json folder. This file contains project information and instant dependency such as Express, MySQL, MySwagger, don't, and it also defines the npm starts and npm run dev. Now, next will be open server.js file. This is most important file. This is entry point and backend application. Now we'll be demonstrate the backend API in Postman. Postman allows the use to send HTTP requests to the backend and verify whether our API is working correctly before integrating them into a React frontend. In my project, I have created 5 APIs: sign up API, login API, and property API, get property ID API, and add property API. First will be sign up API. These API register a new user in the system. It accepts the user's name, email, and passwords. When I click send, request is received to auth.js, then forwarded to auth-control.js file. The controller first checks whether the email already exists. If not, the password is encrypted by Bcrypt and they use details are stored in the MySQL database. If success RUC, the apply API returns user register successfully, which confirms the user has been added the database. If duplicate email, our validation is working correctly because duplicate email registration are not allowed. Now next I will demonstrate the login API. Here see body email send this request goes to the login controller and the control verifies the email and encrypted password from the database. If the both are correct, it generates the JWT authentication token. This token is used for secure authentication and protected APIs. Now open a next get properties. Now I will fetch the available properties. Send show list. The backend retrieves all records from the properties. Tables are returned them as JSON. This same data is displayed later on the React property listening page. Next, add property API. It is given body. This API is used to add the new property into a database. We will be send the request and the As you can see, the property has been inserted successfully into the MySQL. Hit the connected to front end. Now it is the sign up model of my project. This is the registration page where a new user can create an account before accessing the application. The form requires three fields: first name, email address, and password. I will now enter the user details. After filling in the required information, I click the sign up button, and after successful registration, the backend returns the successful response and the application redirect the user login page. Now is the login page. This page allows registered users securely access the application. Enter email. After click the login button, React sends another post request to the login API. Once authentication is successful, the user is redirected to the dashboard. After the successful login, user reaches the dashboard. The dashboard acts as the central control panel and the application. From here, users can access different features of the Urban Reality platform. Point to each section on your dashboard and explain what it is does. For example, this section displays the menu navigation menu. These sections provide quick access to property management. Here, users can view the available properties. Users can also add a new property to the system if your database already contains cards. Thank you overview for listening. This was our of the Urban Reality project. I now hand over the presentation to my teammate who will continue with the live demo. Explain the next section. Thank you.
Hello everyone. Hello everyone. Today I am presenting Travel IQ, an AI-powered travel intelligence platform. The main objective of the platform is to make travel planning smarter by providing personalized recommendation, real-time insights, and seamless user experience through AI. In this presentation, I will mainly focus on the backend development and the authentication APIs that I have implemented. This This slide gives an overview of the project and the travel technology used. Travel IQ follows a REST API architecture for your secure communication between the front end and back end. For development, we are using React for the front end, Node.js with experience for the backend, MySQL as database, and Postman for API testing. Overall, we are using modern and scalable technology as to build a secure web application. Currently, the UI and front-end development are completed. Backend development is in progress and API integration is ongoing. API act as a communication bridge between the front-end and backend, allowing secure data exchange and crowd application operation. Each API is tested using Postman before integration. So for the front end is completed, backend APIs are being developed and integration is in progress. I have developed 7 authentication related APIs: sign up, login, logout, password, the related account, user account, direct user. These APIs manage the complete user authentication process from registration to secure account management. These APIs ensure secure user registration, login, account management, and authentication. An APIs are application programming interface allowing different applications to communicate with each other. In TravelIQ, APIs connect the front-end with the back-end, process user requests, and interact with the database. Each API has specific responsibilities such as fostering user authentication login, testing password login out, or deleting accounts. Simply, APIs are backbone of the application in secure communication between the front end and back end. Postman is an API testing tool. It allows us send API requests, verify responses, debug issues, and ensure every API is coming correctly before integrating it with the front end. All authentication APIs have been tested successful using Postman. Postman helps us validate and test API before they are integrated into the application. Currently, all authentication APIs have been completed and tested. using Postman. Backend integration with the front end is in progress. The next steps are to complete integration, perform and to end testing and deploy the application. The authentication model is complete tested and ready for integration with the front end. Conclude my presentation. Thank you for time and attention. I will have to answer any question. So I am having questions feedback. Now I would like to hand over further part to my teammate.
Thank you for and you explained it well. So I hope I'm audible. So yeah. So before going forward, I would like to explain the all the tech stacks here that we have been used. Uh, so for that reason, I have to share my screen. Just a minute. For this, I have to explain the codes here. So we have the backend APIs flow here, right in the uh, left side. So we have the sign up APIs. Uh, we have sign up APIs along with the backend. So here we can see the sign up APIs here. So we have the sign up API that the API is responsible for the registering the new user. Here you can see. So it first validates the required fields such as full name, then the email, the company name, and the password. So this is the structure for the same, and we have so it will check the whether these are the login inputs are present in the user dimension table or not. So if the user is now new, so the password will be encrypted using the bcrypt hashing. We have already pasted means providing the constraint over here also. So yes, key concept for this sign up route is the it will validate, then check the duplicate records, and also the password hashing. Then the database insertion will become the sign up complete. So after sign up, we will move to the login page. Then it will the login API authenticates here. We can see. So this is all about the sign up group, where we can consider insert the records from the backend, from the front end to the backend. And here is the login page. Yeah. So this is the login route. So login API authenticates the user, and it fetches the user based on the email address and compares the entered password within uh, the particular range. Like we have tamed it to the 10, and with the hashed password stored in the database using bcrypt constant. Also,
if both the match happen, so user details and the password, so it will return to the login page, sign login page. Or we can also pull this request from the MySQL database that we have used here. If we consider if we query select star from the dim user where email is something, so it will fetch the details of the registered email address, and either it will if it not satisfy the condition, it will show invalid email or password. So likewise, uh, after the putting in after the uh, having the valid email address, so it will say login successful. So once you log in into the profile, so it will come to the login logout password logout root, that is the another API we have created. So after the login, it will log in successful, and you can if you check the logout constraint there, so it will log out successful. So no other routes have to pass here. So yeah, it will log out directly. So after that, we also created the delete account API. So it will delete the existing user if the user consider like the permanently wants to delete or remove his account, his or her account. So it will validate first, and then with some queries or the constraints, it will, after verification, it will delete. And so it first verifies the email address that exists already, and it deletes the corresponding record from the dimension table users. So after this, it will show account deleted successfully. So we have also created the another API, that is forgot password, so which has the root. Forgot password API allows the users to reset their password. It first verifies the email, uh, also hash the new password using bgrep, and update the password hash uh, that filled in the database, and returns the successful message. Yeah. Or if you do not miss if that email address does not match, so it will fetch the email not found here. Also we can see in MySQL database, we have the update query, so that it can update via email. And we also uh, verifying with the OTP, so that is not completed yet, so it is in progress. So it will say password update successfully. So these are the five APIs. Apart from this, we have also the customer routes. We have created two APIs here for the customers that are uh, that are related to the users, special users, like or they can also the employees of the company. If they want to travel somewhere, so they can also directly uh, sign up their accounts. So to get all the records, all the customers from, so we can query this on the MySQL database, and after getting some records, so we will see this these queries means after some time. So this is the get method. Then we can also the register customer. So it will consider the body structure, that is the full name, email, whatever the preferences that they are mentioning. So we will see right after this tab. So we can also check the existing customers. After this, we can also insert the customers, like we have the query on the same database MySQL, and after putting some values, it will fetch the records. Either we can consider the levels, that is silver by default we can consider. Also there are some 4 levels like gold, platinum, and VIP kind of. So after fetching these records, it will show customer register successfully. If anything messed up, so it will fetch the error, that like customer error. So likewise, we can get the two APIs, like this API is for register the customer, that is the user details or user accounts, and the get method we can consider for the directory, to check the directory of the user. That is, we have created directory users API for the same. Now we can uh, check this uh, line away. So uh, I have to I have the yeah, this is the dimension users, dimension table of the users table. So these are some records. So if we consider, like if you want to see, uh, there are around 10 means updated records here. Some records already deleted for the um, good understanding. So here we can see, you can see the last record is the Aro Sharma. So first of all, we have to sign up with the new account. Here we can see the. So this is the Postman to test the results. So here we have the endpoint, like API means this endpoint work on the port 3001, and we have the this uh, insertion path. So we have the API auth and sign up. So when we want to sign up with the new records, so it will need some uh, body. But before applying to the body, so we have to post this. You have to use this post method here. So in the body section, we have to insert some records. So to insert some records, I have some another tab open to keep it handy. So once I insert this record, likewise, so when I send this, so it will fetch the record user already existed. So to turn it out, so I have to say, like any name. Let's say its name is like Vikas Sharma, and then I have to say it's Vikas.Sharma at email address. Username also you can either, if you consider username or not, so it will all means it will automatically take the email ID as the username. Then it will take, let's say password is the other one. For these records you can say, consider you can take as it is. So when you put inside insert, so it will say user registered successfully. So once you check the so it's Vikas Sharma, his name is Vikas Sharma, and Arav at the rate 123 is the password. So you have to check here in the database. Once I click this select star from the dim user order by user ID in the descending order, so it will fetch the updated records. So it will say Vikas Sharma is already means is updated here. So means so there is just hold on. Mm, where is my that page? So yeah. log out from this existing. So we have Vikash. Uh, what was the yeah? So this is the email address we have to log in into with the help of this. This is pasted, and then password r @123. I think this is the password. And then once you authenticate, so it will log in successfully. So with the help of that, it can or he can use this platform very well, so that it can plan his journey accordingly. So I have logged in successfully with this API. So once login, means I can log out this profile. Also, so once you log out, you also can forget password or something like that. So if you click means if you enter something else in the password section, it won't authenticate and it won't log in. So for that reason, you entered something else, and somehow you forgot the password. So you can click the forgot password. So it will again uh, fetch the update password. Then after updation, it will ask you. So no, just hold on. So forgot password. You have to enter the new password here, the same email ID, but the new password. Let's say you enter the Vikas @123. Earlier it was Adav @123. Then update password. Yeah, after updation, you can enter the updated password here. Vikas @123. So authenticate. Uh, no. Yeah, it has to be vikas.sharma@gmail.com. Right, like email ID or the username. After that, you already registered, means update the password here. So after, mm, I think I messed up something. Here the email address and the password is, let's say, Vikas @123, and then yeah. So after means once you fill these details along with this, when you authenticate, it will log in successfully. So this was the third API that I have talked about. So after this, you can also integrate this with the delete account. So delete account means user profile. You have to go here. Just hold on. So once you log in successfully, then log out, then forget password. You can also uh, you can also have the endpoints of the delete user. So I have the format here to delete the exact details, like we have the, so anything that you need to put here. So this has the right endpoint here, delete account. So delete account is the this API. With the help of delete method, you can delete that. Okay, so we will fetch the, so yeah, uh, Vikas dot Sharma @gmail.com. Okay, so when you send, so it will fetch. I think I messed up with the email address, I guess. Okay. Okay. Still no. It hasn't had the right format. Yeah. This is the right format. So in this, you have to put Vikas dot Sharma, and after entering, so yeah, uh, yeah. So this is the right way to do it. So it will say successful. So it will say account deleted successfully. So yeah, so these are some records for now. With APIs, we have seen the 5 APIs. So apart from this, we also have the other APIs like for the user. Just hold on. Yeah. So in the user section, uh, I think I messed up with something else, I guess. So here you can see the user details here, and earlier it was running, but still I have some uh, errors. I might have to be, I might have to check here furthermore. So in the user section, you can see all the details of the users and the directory users. So for now, uh, yeah, so this was the overall architecture of the backend and the front end. So these, if I conclude this, uh, the both the terminals. So the React front end provides the secure and responsive and the user friendly interface that integrates the seamless interaction with the backend APIs that deliver the complete end-to-end experience for the Travel IQ platform. So now onwards, I would like to hand over to the director, sir. Thank you for have patience, having patience in that. So please go ahead, sir.
Hey, thanks everyone who contributed in this live stream. You did extremely well being an intern and developing a backend code for your white label applications. The motive of this entire stream is to review the entire progress, how you guys are developing the applications under the guidance of your tech leads. I hope everything related to the application, their objectives, and the API development process is clear to all of you. At the same time, you did good job to give us the review on it. I wish you best luck. We'll see you again in the next live stream with a different agenda of your project development review. Have a good one. Thank you.
In Axiom Tech Guru, we transform ideas into scalable digital solutions with AI, innovation, and technology that drives real business growth.